Good morning, students. Let us start the ITC class. In the yesterday's class, we had seen a special matrix called joint probability matrix. And in the previous class before that, we had seen one matrix called channel matrix or noise matrix. And in yesterday's class, we had seen the properties of joint probability matrix as well. The elements of the joint probability matrix or JPM contained all conditional probabilities as well. So, those who had been absent yesterday, you will have to go through the video that is posted in my channel, and you will have to become familiar with all these terminologies as well as the properties of the joint probability matrix. Now, if you don't remember those properties, whatever I am going to discuss from now on in this particular module is going to be a puzzle for you. You will not be able to understand anything from now on in this particular module unless you have revised the previous topics that were covered in this particular module. Okay, let me proceed with today's discussion. We are going to discuss something called as entropy functions and a special term called equivocation. It is not vacation, it is vocation. In general, vocation means what? In general, vocation means utilization of the time. Okay. So, equivocation means, in fact, vocation does not mean only the utilization of time. It is the utilization of time as well as the available resources for some useful task. We can say that way. Vacation means utilization of time for relaxation or for resting or for whatever. That is called vacation. Vocation means utilization of time and resources for doing something useful or doing something great. That is the meaning of vocation. So, equivocation in information theory. Why this vocation came into picture? Because here the receiver has to make use of the available resources and the receiver has to make use of the adequate time. Why time comes into picture here? The reason is when a transmitter is sending a stream of data. In fact, transmitter is not sending, transmitter will be pumping a stream of data into the channel because we are in the era of gigabits per second. So, you can think in a second 1 gigabits are going to be forced into the communication channel. Now, at the receiver side, it has to receive all these 1 gigabit per second, imagine that way, and then it has to store all those bits in the memory, and in the memory it has to go for the data processing. In addition to that, now it has to detect the errors and it has to correct the errors, then it has to produce the corrected output, error corrected output. Now, you just think about this process where transmitter is going to have a data in its memory and there is a processor that is going to process this data, and later on this data is going to be converted from parallel to serial, and after that there is source encoding, channel encoding and modulation and all other processes are happening. After which this data which is coming in the serial fashion in the channel, whether it is a wired channel or a wireless channel, it is coming all the way to the destination. There the demodulation is going to happen, and again channel decoding has to happen, source decoding has to happen. Finally, it will go back again into the system's memory where serial to parallel conversion will happen, and after the serial to parallel conversion, the parallel data is going to be output. Think about the complication now between the transmitter and the receiver. Think about the complication, but the wonderful thing is it's all working within few microseconds or maybe nanoseconds. Why? Because we are using the communication systems which are also using a processor which can work at gigahertz speed. In fact, because of the advent of VLSI, even the communication systems got improved a lot. Because our communication systems are now completely digital and they are being controlled by processor and memory together, and because of that, when the processor can work with the gigahertz speed and the processor can access gigabytes of memory within itself, that is when even this error detection and correction can happen at a much faster pace. Why am I telling all these things again is, just visualize how much time the receiver should take to detect the error and to correct the error and to produce the corrected output. I have been telling you about the concept called latency. Latency means a delay which is present between the transmitter and the receiver, and at times the delay cannot be eradicated at all because delay is part of the system. Earlier we used satellites for ISD calls and latency was inadvertent there. In the sense, even if you make a call to Sri Lanka or Bangladesh also, even though they are our neighboring countries, they used different satellites, India used different satellites, so there used to be satellite to satellite communication also. So there used to be latency always in the ISD calls. But now, even if you make a call to USA or Japan, now you don't experience this latency because of the usage of optical fiber. Now, think about information theory and think about the receiver which is going to receive gigabits of data, and then it has to detect the error, it has to correct the error, it has to produce the output. But this delay which is happening within the system should not be experienced by the user. I'll give one more example. Let us say you have a DVD and in the DVD there are a lot of scratches. And imagine you have a very efficient DVD player. Now, from the DVD through the laser lens, the data is going to be read by the DVD player's processor. Now, this processor has to detect the error and correct the error, and the corrected output should be given to the television, so that the audio and video can be displayed on the screen. Now, between it reading the DVD and when you experiencing the movie, there should not be a latency, isn't it? Now, that is the challenge of the design with the DVD player. How fast the CPU will detect the error and it will correct the error and it will output it to the television screen or to the television. Actually, television will not do any error detection and error correction. Television will simply convert the video signals into light and audio signals into sound, and you will experience the movie. But all this is happening in the DVD player itself, because there are errors in the DVD surface, errors on the DVD surface. Now you think about the delay that happens after reading the data from the DVD and before transmitting it to the television. In between, there must be this error detection and error correction. That means the processor should effectively make use of the time also at that time, and it has to make use of the resources. They are nothing but the memory which are belonging to the processor. That is what is called as vocation. Okay, now why is it called as equivocation? Equivocation means between transmitter and receiver, there must be a synchronized working style now. Because the transmitter will keep on sending data. Receiver cannot say that, wait, I am still correcting errors. Wait, I am still detecting errors. Wait, don't send me anything more. It cannot say. When the DVD is playing and when continuously from the DVD it is reading the data, and when the processor which is inside the DVD player is transmitting the data to the television, now the CPU which is inside the DVD player cannot say to the laser lens that, wait, don't read from the DVD. I am busy in detecting error and correcting error. That becomes so funny, and that should not happen also. So there is nothing called something telling to something else that you wait, I am not yet ready. Such situation will not occur in case of communication. Machine to machine communication, I should say. Between human to human communication, we may say that wait, I am not ready. Wait, I am not listening. We can say all that. But between machine to machine, there is no such thing. For example, as a human being, when you are watching a movie, you can always press the pause button in the remote and you can make the DVD player to wait. That is the controlling command you are giving to the machine. The machine has no freedom to pause on its own. The machine will pause on its own only when the machine is failing or machine is malfunctioning. So that is why this term is called as equivocation. Means equally transmitter and receiver will be working together. Actually, transmitter will not be bothered about the errors that are happening. Receiver is bothered about receiving the transmitted bits also and the errors that are happening in the channel also. But why then we call it as equi? Now that is because of the Bayes theorem. What does the Bayes theorem say? That from the destination side, we are now characterizing the source side. Based on the bits that are received, we are going to predict the bits that are transmitted from the transmitter. That is what is the essence of Bayes theorem, right? Based on the symbols that are received at the receiver, we are going to characterize or finding out the probability of emission of a particular symbol at the transmitter. So we cannot completely ignore the functionality of the transmitter as well. That is why the term is called as equivocation. Now with this introduction about this particular special term called equivocation, remember this, it's a special term and we are going to have a mathematical definition for this term later on. Now, the entropy of the input symbols before their transmission is referred as priori entropy. That is, H of A is summation of I equals 1 to m of P of AI into Lg of 1 over P of AI. This we are already familiar. The entropy of the input symbols after the transmission and reception of a particular output symbol Bj is defined as the posteriori entropy or conditional entropy. Now think about the priori entropy. Priori entropy is nothing but the entropy at the transmitter itself without bothering about the reception. That means before their transmission. Now the entropy of the input symbols after the transmission and reception of a particular output symbol Bj, that is defined as posteriori entropy or conditional entropy. We have already seen the conditional probability. Now naturally, when we have the conditional probability, we should have conditional entropy as well, which is H of capital A. Capital A is the complete source. Imagine this capital A indicates all the symbols that are at the information source, whereas Bj is a particular symbol received at the destination. So H of capital A in condition with Bj, I will pronounce it as H of A slash Bj equals summation of I equals 1 to m P of small ai slash Bj, means when we transmitted AI, we received Bj. In the sense, when we received Bj, we must have transmitted AI. Now Lg of 1 over P of AI slash Bj. We are using the conditional probability here for a respective output symbol. Now we have a respective input symbol. In other words, for the respective received symbol, we have a respective transmitted symbol. Now for all those symbols which are at the source, I equals 1 to m, you can see AI here, I equals 1 to m. For all those source symbols, we will have to compute this value and then that is called as conditional entropy or posteriori entropy. The average value of all the conditional entropies is defined as equivocation. Okay, let me underline this. The average value of all the conditional entropy. Look at this. We are finding out a conditional entropy for a given received symbol. That means only for Bj, we are finding out the entropy for all the AI, I equals 1 to m. Now we have to find out this value for all the received symbols with respect to the transmitted symbols now. Now here it is only I equals 1 to m, and now there will be j equals 1 to m also. So the average value of all these conditional entropies, that is defined as equivocation. Now we will try to formulate equivocation in terms of mathematics. Then we will show you a graphical picture where you will clearly understand this. So what is equivocation? Let us see. Let me slightly zoom in. Okay, we write it as h of a slash b. Entropy of the source with respect to the destination, or entropy of the transmitted symbols with respect to the received symbols. H of a slash b is expectation of h of a slash small bj. That is expectation. Expectation itself is a statistical term. And I had asked you earlier to revise all your knowledge of probability and statistics. I cannot do all that in this course now. I hope you have done the revision of that. Those who have not yet done the revision, please revise the knowledge of probability and statistics once again. That is going to be helpful to you for many other courses also in future. So, expectation of this h of capital A slash small bj is summation of j equals 1 to m. I had told you earlier, j equals 1 to m of p of bj and h of capital A slash bj. Now this h of capital A slash bj we had already defined earlier as a conditional entropy, isn't it, or posteriori entropy. Now let us substitute for this h of a slash bj. So summation of j equals 1 to m of p of bj into summation of I equals 1 to m of p of a slash bj lg of 1 over p of a slash bj. So we have this conditional entropy with respect to a particular received symbol. And now we have that for all the received symbols. We know that p of bj into p of ai slash bj is equal to p of ai comma bj, where we use the notation comma. You will have to remember whatever we discussed in the last class. When we wrote the joint probability matrix, we use this particular notation. Why? We cannot keep writing this lengthy expression in our matrix. That is why we simply write p of ai comma bj. It simplifies our life so that we can write a smaller notation and I can indicate a bigger relationship. Now using the same notation here, what we can do is, we can simply write h of capital A slash capital B equals summation of I equals 1 to m and summation of j equals 1 to m and p of ai comma bj, because you can see here p of bj into p of ai comma bj is, sorry, p of bj into p of a slash bj equals p of a comma bj. Now that can be written here directly because anyhow it is summations, summation within summation. We can write it this way and we can write lg of 1 over pi of p of ai slash bj. Now this particular equation represents what? This particular equation represents the uncertainty of A when B is received. In other words, the equivocation of A with respect to B represents the amount of information lost due to noise. The equation represents the uncertainty of A when B is received. Remember, we are using the Bayes theorem and we are characterizing the source in terms of the destination. So when B is received, we want to find out how much uncertain A is. Okay, that is what is represented by this particular term, because it is conditional. It is all based on the conditional probability. That is evident here, right? P of ai slash bj means it is the probability of ai with respect to bj. When bj is received, what is the probability that ai was transmitted at that time? So that way there is uncertainty When there will be uncertainty? When the expected one is there and the unexpected one is received, then there is uncertainty. For example, you may be expecting a letter from your friend, but you might be getting a letter from your father. Now there is uncertainty. You may be expecting a letter from a friend about some picnic or trip or whatever, but you may receive a letter from your father asking for the account for the money spent in the previous month. now there is serious uncertainty. Okay. Coming back seriously to the subject, equivocation is what basically now? It is conditional. That means there is uncertainty. Uncertainty itself is because of channel's characteristics. There will be interference, there will be noise, there will be fading, there will be attenuation, many things. So, this equation represents the uncertainty of A when B is received. In other words, the equivocation of A with respect to B represents the amount of information lost due to noise. Now we can characterize the complete communication system in terms of equivocation. Let me discuss that now. If h of A slash B equals 0, then the channel is errorless, right? If AI is transmitted, if BI is received. On the other hand, let me use BJ instead of BI. On the other hand, no, let me use A1 and B1 only, that is better. When B1 is received, it is certain that A1 is transmitted. When B2 is received, it is certain that A2 is transmitted. If this happens for all the source symbols and the received symbols, then we should say that h of A slash B is 0 and the channel is errorless. But that particular part is very, very rare. Channel is not ideal as such. This means that when A equals I and B equals I and average conditional entropy is 0. When the average conditional entropy, see, it is called average conditional entropy, that is 0 because this is based on the conditional probability. When the average conditional entropy is 0, that means the channel is errorless, the channel is ideal. On the other hand, if h of A slash B equals h of A, then the channel is completely noisy and unreliable. Think about this. H of A slash B equals h of A. This means what? All the information is at the source itself. We want all the information that is at the source to be received at the destination. But we are applying our mathematical analysis and we find out that h of A slash B equals h of A means that the source is not at all having any statistical dependency on the destination as such. Source and destination are not at all related that way. For example, your friend wrote a letter to you writing your address, but the postman delivered the letter to someone else. Imagine that way. That means the data did not receive. Data was not received by you at all. And the postman may be least bothered about which letter went. And the person who received that letter, it may not be belonging to that particular person. He may simply throw it to the dustbin. That's all. The letter is lost. Which means the channel is completely noisy and unreliable. Here the postman is completely unreliable. Which means the information which the source sent is with the source only now, even though the letter was sent. Whatever was the information written in the letter by your friend, that even now the friend only is having, now you are not having. That means communication did not happen at all. Please understand all these things. I am giving you some funny examples only to make you understand. You already know that I am a very funny person that way. Okay, let it be. You can take me lightly, but don't take the course lightly or don't take the understanding lightly. I am also not making the understanding lightly. I am only making the presentation lightly, isn't it? Let me come back. On the other hand, if h of a slash b equals h of a, then the channel is completely noisy and unreliable. So, when we compute this equivocation for the given communication channel, we will come to understand the efficiency of communication in terms of the channel. In other words, B does not contain any info about A. Later on I am going to show you the diagram. In other words, B does not contain any info about A. Why? H of A slash B equals H of A itself. All the information that was transmitted by the source is with the source itself that way. In other words, B does not contain any information about A, and hence A and B are statistically independent. If H of A slash B is equals H of A, then they are statistically independent. On the other hand, if H of A slash B equals 0, what does it mean? H of A slash B equals 0, what does it mean? It means that all the information is received at the destination, because it is conditional entropy, right? So, it is neither the source entropy nor the destination entropy. Remember this H of A slash B is neither the source entropy nor the destination entropy. It is the conditional entropy. Now, if the conditional entropy is 0, means communication is very much effective. If the conditional entropy is equivalent to source entropy, means nothing went to the destination. In other words, B does not contain any information about A, and hence A and B are statistically independent. And then H of B is only due to noise. You will still get some symbols. You will still get some symbols at the destination. But what are those symbols? All those symbols are because of the noise. And then H of B is only due to noise. Okay. At times it may happen that you may be listening to an FM radio, and due to some problem, maybe at the transmitter or maybe at the channel, due to some problem, suddenly you may hear only some sounds, some strange beating sounds or strange cut sounds or change sounds. Now, these sounds are not transmitted by the transmitter. These sounds are from the channel itself. Now, the channel may be giving that noise to you. You still will receive those noises, right? That means H of B is not 0 there. At the destination, entropy is not 0. But the only thing is, at the destination, the source information did not come. So, in such case, H of B is only due to noise. Many times, even during your mobile phone calls, especially during this time of pandemic, where network is highly utilized by everybody, whenever you have some mobile phone calls, suddenly you may feel as if from the other side the person is speaking, but the exact wordings are not coming in your mobile phone. Some other strange sounds are coming. Which means what? Because of the network issues, the channel introduced its own noise, and signal to noise ratio became much larger. The signal to noise ratio crossed its threshold, and whatever you received is only the noise. You did not receive the signal. Now, that way you will still receive some symbols or some information at the destination, but that is not relevant to the one that is sent by the source. So, in such a case, we say H of B is only due to noise. Now, this can be indicated as follows. Look at this picture. Now, this is a beautiful picture. If you can understand this picture, you have understood everything whatever I have told you till now. Look at this. We have one circle at the left hand side, and we indicate it as H of A. The complete content of the circle at the left side is the source entropy. And we have one more circle at the right side, that is the complete information content at the destination, that is H of B. Now, there is a joint entropy H of A comma B. It is the sum total of the information content of both A and B, that is a joint entropy. We have given the symbol H of A comma B. That comma is a notation there, you already know that. Now when the circles are overlapping, what does it mean? When the circles are overlapping, in between them there is this I A semicolon B. We are specifically using the symbol semicolon in between. And what is the I A semicolon B? Now that is called as the mutual information. That mutual information means out of H of A, this much of information is actually received at the destination. Because I of A semicolon B is part of H of A also, it is part of H of B also. Now, there is a shaded portion here, H of A slash B. Now, that is what we are calling as equivocation. We have it at the destination side as well, H of B slash A. Now, they are all converse actually. We need not bother much about H of B slash A. If we understand H of A slash B, its other counterpart at the destination is H of B slash A. Now, we have been telling about this H of A slash B, right? Let me go back. If H of A slash B is 0, then the channel is errorless. On the other hand, if H of A slash B is H of A, then the channel is completely noisy. Now, what do you understand in this diagram? If H of A slash B is 0, then what will happen? Both these circles will completely overlap. H of A and H of B will completely overlap. When they completely overlap, all the information content of the source is received at the destination. Now that is an ideal channel. You can also say that H of A and H of B, where they are overlapping, means what happened to this I is semicolon B? The complete mutual information is nothing but H of A, complete source information, which is complete destination information. So then the circles will overlap. Now on the other hand, that was the first case. First case was if H of A equals 0, then the channel is errorless and these two circles will overlap. On the other hand, if H of A slash B equals H of A, what does it mean? If H of A slash B equals H of A, then these two circles will never touch each other. These two circles will remain separate. When these two circles remain separate, what does it mean? It means that I of A semicolon B is not there at all. Mutual information is not there at all. That means whatever is sent from the source H of A did not reach the destination H of B at all. Still H of B will be there. That H of B will be only due to noise, nothing else. So visualize and remember this diagram. If these two circles are completely overlapping, then that is an ideal channel. If these two circles are not at all touching, then it is a completely noisy channel. We will have two extremes now. One extreme is complete ideal, another extreme is completely non-ideal. Or completely, I cannot say completely non-ideal, I should say completely noisy. One is 100% noiseless, other one is 100% noiseful. These are two extremes. All our systems are working in between these two extremes. Now, it means what? If these two circles are completely overlapping with each other, then we have an ideal communication. If these two circles are not at all touching each other, then it is a completely failed communication. We will have something in between. Now the conclusion is, if I of A semicolon B is larger, then we should say that a larger amount of information is received at the destination. So, in the practical cases, we should have I of A semicolon B much larger. Now, for finding out this mutual information, we should find out the equivocation. Why? From the diagram, you can easily write an equation. Without any mathematical derivation, you can easily write an equation. That equation is H of A equals H of A slash B plus I of A semicolon B. Similarly, you can write from the destination side, H of B equals H of B slash A plus I of A semicolon B. Right? You can easily write it. Now, there is something called H of A comma B. For this h of a comma b also, you can easily write one more equation. What is that? H of a comma b equals h of a plus h of b slash a. Similarly, you can write h of a comma b equals h of a slash b plus h of b. See, this diagram is quite useful that way. If you remember this diagram, you will write all those formulae on your own without any mathematical derivation. Otherwise, later on we have some mathematical derivations as well. Ultimately, because of the mathematical derivations only, now this diagram is being written, isn't it? Otherwise, h of a is also a mathematical content, h of a slash b is also a mathematical content, I of a semicolon b is also a mathematical content, and h of a comma b is also a mathematical content. Ultimately, in information theory, there is a lot of mathematical content only. Entropy itself is a mathematical content. But you will have to remember this diagram thoroughly. Keep on looking at this diagram and keep on remembering this diagram thoroughly. Today night, if you get this diagram in your dreams, then I will be so happy that today's class was really useful. Because based on this diagram only, later on we are going to solve our exercises. If you remember the diagram, you can remember all the expressions as such. Actually, you can write all these expressions on your own, isn't it? Now you can write h of a comma b equals h of a slash b plus I of a semicolon b plus h of b slash a. That way also you can write. There are many ways of writing these expressions. Sometimes all these expressions on the LHS and RHS will be many times one and the same. In the sense, you may have two expressions which may mean the same thing now. For example, we can write this I of a semicolon b equals h of a minus h of a slash b. We can also write I of a semicolon b equals h of b minus h of b slash a. We can write both are one and the same now. The end result is one and the same. So based on whatever we know, we can compute whatever we don't know. So you should remember this diagram. I'll keep on showing this diagram whenever later on also when we solve these exercises. With this discussion, let me proceed further. The term h of a comma b represents the joint entropy, which can be directly computed from the joint probability matrix. See, this whole thing is now joint entropy. Joint entropy means the entropy which is both with the source and the destination, and the entropy which is mutual, right? We can write this h of a comma b as h of a plus h of b slash a. So there is this b along with a. We can also write h of a comma b as h of a slash b plus h of b. Again there is a with b. So naturally it is a joint entropy. The term h of a comma b represents the joint entropy, which can be directly computed from the joint probability matrix. Now for this purpose only we will have to have this GPM. The term h of a minus h of a slash b represents the balance of information received at the receiver with respect to an observed output symbol. Hence, this difference is called as mutual information. That's what I have been telling you. This is going to be given the symbol of I within parenthesis a semicolon b. So, please remember the term h of a minus h of a slash b represents the balance of information received at the receiver with respect to an observed output symbol. Remember that bj, that was the definition we gave earlier. So this difference is called as mutual information. Or I of a semicolon b equals h of a minus h of a slash b. Now you may think, why are we using this semicolon here? Why can't we use comma here? Please remember, when we put comma, it can be joint. Whereas when we put semicolon, it is mutual. There's a difference between joint information and mutual information. right? Joint means it can be always added. Mutual means it is not added, it is common between both. That way, we are specific about the usage of these symbols. So, you will have to be careful. You cannot write as I of A comma B. You should always write as I of A semicolon B. And we can write it as H of A minus H of A slash B if H of A slash B is 0. Okay? If H of A slash B is 0, then the two circles will be of equal size and will overlap with each other fully as H of A equals H of B. This is what I told earlier. This means that the channel is ideal. In such a case, H of B slash A equals 0. I of A semicolon B equals H of A. Right? See, H of A slash B is 0 means I of A semicolon B is H of A. That means all the source information has become the mutual information. That means the channel is ideal. Similarly, on the other hand, if H of A slash B equals H of A, then the two circles will not overlap with each other at all. This also I had told. The two circles will not overlap with each other at all, which means that the channel is completely noisy. In such a case, I of A semicolon B equals 0 when H of A slash B equals H of A. What does it mean? I of A semicolon B equals 0 and the two circles may or may not be of equal size. Why this is so? Can anybody tell me? Those who have understood this discussion, can anybody tell me the two circles may or may not be of equal size? I want someone to answer this question now. Can anybody tell me why it can be may not be? Anybody? Somebody? Nobody? Oh, I have 23 students listening here and I doubt whether they are listening. Okay, in the chat box, entropy differs between A and B. No, sir. Yes, sir. Correct, sir. Entropy differs between A and B. Why? The reason is, you may get more noise at the destination, right? When you get more noise at the destination, when the signal to noise ratio has crossed the threshold, you may get more noise and that noise also will have some symbols. So in such a case, at the destination, the circle may be of larger size. You may get H of B which is much larger than H of A. Or if the noise is lesser, then also you may get H of B that is smaller than H of A also. But they can be completely irrelevant where the circles will not touch at all. So in that case, I of A semicolon B will be completely 0. Now can we deduce that from this equation? I of A semicolon B can be 0. How can we write 0 at the LHS? I of A semicolon will be 0 if these two are equal. H of A minus H of A slash B, if they are equal, you can come back to the diagram and see. See, H of A and H of A slash B, if they are equal, then there is no I of A semicolon B at all. And the circles will not touch with each other at all. Actually, we cannot say at that time that this H of A slash B has some relevance at all. Right? So, if these two are equal, then it means that nothing is received at the destination. That is H of A minus H of A, that is going to be 0. That is the meaning here. So, okay. So, please remember this. The next topics I am going to discuss in the next class because it's already time now. So, remember this particular diagram. I of A semicolon B, mutual information can be 0 when the two circles will not touch at all. And the mutual information will be maximum or 100% when the two circles completely overlap. So again I'll come back to the diagram. You will have to remember this diagram thoroughly. I will write a square box around this diagram so that you will remember. Okay. Now remember this diagram thoroughly. Always visualize one circle h of a, one more circle h of b, overlapping slightly in between I of a semicolon b, and LHS of this left circle is h of a slash b, RHS of the right circle is h of b slash a, together it is h of a comma b. So h of a comma b is the joint entropy, whereas I of a semicolon b is the mutual information. And h of a slash b and h of b slash a are called as respective equivocations. Now please remember all these terminologies. In the next class we will go into